Okay, this video is modeling exponential and power functions. And the way I do this, and I set this up, is it's going to practice finding an exponential function first, and then we're going to use those same 2 points to show you that you can actually do a power function. The one thing I do want you to recognize is that your power functions, if you'll see the formula, is y equals kx to the p. And if you'll notice, the x is down low, if you will, and there's a power, and that's the difference between y equals ab to the x, where the variable is up high as an exponent. So that's how you can tell them apart. And I'm going to do one of each so that you can see how to do this. So the first one is, you're going to do this, and I look at my points, and I'm going to stack and rack them. So my first point is 212. My second point is 575. Because I don't know the initial value, I'm going to use the formula y equals ab to the x, and I'm going to just plug in the points in the xy spot. So I have 75 equals ab to the fifth, divide, 12 equals ab squared. Thanks for playing. So I have b cubed equals 75 over 12. And then I'm going to raise both sides to the 1/3 because I want to know what b is, or the growth factor. And I get b to be 1.8420. And I'm happy about that because the function looks like it's growing. And that just means, as we all know, is that that's growing about 84.2%. And that's what the b stands for. Now we want to look for a, so I'm going to take and say y equals a, 1.8420 to the x, and then you can choose whichever one you want to choose. I'm going to choose the top point, the 212. So I'm going to say 12 equals a, 1.8420 to the x. So I just put in the x and y spot. Yes. And in the X spot, I want to put, I'm going to erase that. I'm going to erase this right here if it lets me. Yes. In the X spot, I want to put what the X is to that point, and the X is a 2. So I actually put in the point 212 in the X and Y spot. Now this is hooked to the A by multiplication. So A is going to be 12 divided by 1.8420 squared. And that's roughly comes out to be 3.54. So using these 2 points, I came up with a formula that would model that. And the formula, I'll just put right here, is going to be y equals 3.54, that's the initial value, 1.8420 to the x. So there's that formula. Now the second one, we're using y equals kx to the p. So now, because you know how to do that, we're going to actually practice doing that, and it's very similar, and you'll see why I have to wait to show you after I do logs. But we're going to take this same 2 points of 212 and 575. So I have 212 and 575. All right, so now what I'm going to do is actually do the same thing, except I'm going to plug it into the other formula, y equals kx to the p. So I have 75 equals k. The 5 is now the base to the p. Divide. 12 equals k 2 to the p. Then I can say thanks for playing. And then remember our rules that if the powers match but the bases don't and they're dividing, we can write it like this. 75 over 12 equals 5 over 2 raised to the power p. Now I'm trying to solve for the power, so now I have to undo that. So I'm going to natural log. So I have the natural log of, looks a little messy, the natural log of 75 over 12 equals p natural log of 5 over 2. And since I'm solving for p, I'm going to divide by the natural log of 5 over 2. P is the natural log of 75 over 12 divided by the natural log of 5 over 2. And this comes out really nice when you put this in your calculator. You get p to come out to be 2. Now I'm going to go through this just like I did before. I know what the power is, so I have y equals kx squared because I know what the power is. And you can plug in one of the points. I'm going to use the same one too, 12, just because it's smaller. Everything's positive. So I have 12 equals k 2 squared. 2 squared is 4, so k is 12 divided by 2 squared, or 4, or 3. So this beautiful formula, this one's a lot nicer looking, is the k comes out to be 3, the x is down here, and it's 3x squared. So you're using the same type of method to find them, and that's why it's good to practice, and you've used that before. Now these two, again, you're going to do this over and over again. I have this all worked out, but if you want to try it yourself, this is y equals 0.257. That's a point right here. 0.4387 to the x. This one is y equals negative 1/6 x cubed. So if you want to try doing that. So there's 4 of them here that I would have you do if you need practice. And we actually did 1 and 3 in class. So this one is y equals 6 1/4 to the x is our formula, and y equals 3/2 x to the negative 2 for our power formula. This one down here is a nice one to use, except I made a mistake. I really want this to be positive and this to be positive. So if you want to use that one, just change those so you'll get a good answer. So this comes out to be y equals 53.86 0.021544 raised to the x. And this one comes out a little bit nicer, y equals 1/5 x to the negative 3. So there you have it. There's some practice and the answers. Again, this is all online, so you can practice this, and I have all the solutions there. I did 1 and 3 again in class to have everybody practice, but this isn't for homework, but I just wanted to make sure that you were comfortable finding power functions just like you're just as comfortable finding exponential functions. So that's the end of this video.